You need to watch this if you struggle with understanding modern technology. In today's world, technology is an integral part of our daily lives. From the moment we wake up to the sound of an alarm on our smartphones to the time we go to bed after browsing the internet, technology surrounds us. But have you ever wondered what makes all these devices work so seamlessly? What is the magic behind the screens of your gadgets? The answer lies in a tiny yet powerful component that has revolutionized the way we live, work, and communicate. The key to it all? The humble transistor. This small but mighty component is the heart of modern electronics. It is the building block of all the devices we use today, from the simplest gadgets to the most complex machines. The transistor has transformed the world of electronics, making it possible to create smaller, faster, and more efficient devices. But what exactly is a transistor, and how does it work? At its core, a transistor is a small electronic component made from semiconductor material like silicon. Semiconductors are materials that have properties between those of conductors and insulators, making them ideal for controlling electrical currents. The process of manufacturing transistors involves creating intricate patterns on silicon wafers, which are then sliced into individual chips. These chips are the brains behind all modern electronic devices, enabling them to perform a wide range of functions. Think of it as an electrical gatekeeper. It can switch signals on and off or amplify them, making it essential for all modern electronics. When a small electrical signal is applied to one part of the transistor, it can control a much larger current flowing through another part. This ability to control electrical signals is what makes transistors so versatile and powerful. They can be used to amplify weak signals, switch electronic circuits on and off, and perform complex calculations in microprocessors. There are two main types of transistors you'll come across. Bipolar junction transistors, or BJTs. BJTs are made up of 3 layers of semiconductor material, with each layer having a different type of doping. The 3 layers are called the emitter, base, and collector. The emitter is heavily doped to inject a large number of charge carriers into the base, which is lightly doped and very thin. The collector is moderately doped to collect the charge carriers from the base. When a small current is applied to the base, it allows a much larger current to flow from the emitter to the collector. And field effect transistors, or FETs. FETs, on the other hand, use an electric field to control the flow of current. They have 3 terminals called the source, gate, and drain. The source is where the current enters the transistor, the drain is where it exits, and the gate controls the flow of current between the source and drain. When a voltage is applied to the gate, it creates an electric field that either allows or blocks the flow of current. FETs are widely used in digital circuits because they consume less power and can be made very small. BJTs use a small current at the base to control a larger current between the emitter and collector. This makes them ideal for applications where amplification is needed, such as in audio amplifiers and radio transmitters. BJTs are also used in switching applications where they can turn electronic circuits on and off. Their ability to handle high currents and voltages makes them suitable for power applications as well. On the flip side, FETs use an electric field at the gate to manage current flow between the source and drain. This makes them ideal for digital circuits where they can switch on and off very quickly. FETs are also used in analog circuits where they can amplify signals with high precision. Their low power consumption and small size make them perfect for use in portable devices like smartphones and tablets. Transistors are everywhere, from the simple amplifiers and hearing aids. Hearing aids use transistors to amplify sound signals, making it possible for people with hearing loss to hear more clearly. The small size and low power consumption of transistors make them ideal for use in these tiny devices, which need to be worn comfortably for long periods. To the complex microprocessors in your computer or smartphone. Microprocessors are the brains of modern computers and smartphones, performing billions of calculations per second. They are made up of millions or even billions of transistors, all working together to process data and execute instructions. The incredible speed and power of modern microprocessors are made possible by the tiny transistors that make up their circuits. Without them, the digital age as we know it wouldn't exist. The invention of the transistor in the mid-20th century marked the beginning of the digital revolution. Before transistors, electronic devices relied on bulky and unreliable vacuum tubes, which limited their performance and reliability. The development of transistors allowed for the creation of smaller, faster, and more reliable electronic devices, paving the way for the digital age. Today, transistors are at the heart of everything from smartphones and computers to medical devices and space exploration technology. So next time you pick up your smartphone, remember, it all started with a tiny transistor, revolutionizing technology in our lives. The next time you use your smartphone to make a call, send a message, or browse the internet, take a moment to appreciate the incredible technology that makes it all possible. The tiny transistors inside your device are the result of decades of innovation and engineering, and they continue to drive the advancement of technology. From the first simple transistors to the complex microprocessors of today, these tiny components have changed the world in ways we could never have imagined. And as technology continues to evolve, transistors will remain at the heart of the devices that shape our future.